I'd like to show you guys how I get 125 amps of grid pass-through with my single Magnum 4000 watt inverter. I had a lot of issues running any kind of amperage through the inverter from the grid, and I fried a few connections, so I came up with this simple fix. Basically, I have this 125 amp contactor that has a normally open and normally closed slots, so there are 4 different areas to put wire in. So basically I jumpered the normally open and the normally closed contactors together, and there's no interference there. You can see how I've line 1 on the left and line 2 on the right, and the wires that are going into the wall go to my main panel in my house. And then on this other side, you can see the center is the normally closed, and that comes from the grid. And on the outside ones, that's the normally open ones. And you can see I have a white wire and a black wire with a white stripe, and those go directly to the contactor coil. Now I have the house running on the inverter right now. So basically every time that the inverter turns on, it automatically switches over to inverter power. And it does it without any disruption in my internet or any electronic devices. It's very quick. So whenever I turn this inverter button, whenever I press it and shut off the inverter, I'll show you how quickly it switches over. Just like that. Very quick. So now with the inverter turned off, I am running strictly on grid power. And to go back onto inverter power, all I have to do is turn the inverter on and it automatically changes over. Just like that. Very quick and easy. The one downside of using this method is that you can't use the onboard charger onboard the Magnum inverter or whatever inverter that you're using. And if you've ran it off of generator power for any amount of time, you've probably already fried your charging board in the Magnum anyway, so it doesn't matter. But what I like to do, I have a outlet here that is grid power when the inverter is off, or it is inverter power with the inverter on, but what I do is I have a small charger that keeps these batteries at a certain voltage, and that way it's charging off of grid power, or making sure that the batteries are ready to be backed up. If the grid goes down for any reason, then the batteries are already charged. I wouldn't recommend a high amperage charger in this scenario, because once you do start running on inverter power and the charger kicks on, that limits your amount of available power by that much, and the inverter is self-consuming a bit in that scenario. So a smaller charger is better in this scenario. I'll now give you a better explanation of how it's wired up and more video angles. So down below is the coil. You can see it's a 240 volt, 50 or 60 hertz. So I'm running 240 volts through that from the inverter. This is a 240 volt inverter. That's a live wire right there. That's line 1 and line 2 from the grid, straight through the center, which is what I'm running on right now. That is the normally closed position that it's in right now. And then when it's ready to be switched over to normally open, the wires on the outsides create 240 volts and switches itself into inverter power when the inverter is putting out power. And so if there's ever any issue with the inverter, it'll automatically default to grid power. And then on the other side, you can see the line 1 jumper, the black wire, that goes from the normally open position on the outside to the normally closed position on the inside and piggybacks with the wire going to the main panel. Now, sharing a terminal space for 2 wires is not permitted by code, but this is my house. So that's line 2. Don't tell OSHA I said that. Line 2's there. Same thing. Being piggybacked in that center slot. Nothing to it.